Okay, simplifying radical expressions. You can use this sheet on the test. Here's a radical sheet, you use that too. Okay, so we're going to be on this side to start with. This is a side I use when there are no adding and subtracting operators. So I'm going to set this up to use properties of exponents. Now first, if you see a radical, you need to rewrite the expression without the radical. So you make a parentheses to the 1/3 power. And we have 250 x to the 7th, y to the 9th. Okay, line 1, write the bases, apply exponents. You get 250 times x times y. 1 times 1/3 is 1/3. 7 times 1/3 is 2 2/3. Yup. Or 2 1/3, my bad. 2 1/3. 9 times 1/3 is 3. Okay, if you have a negative exponent, rewrite it below. Don't have it, next step. Transfer all whole exponents to line 2. So this 2 and 3, we put x squared times y 3. You can now cross those out. Now let's see if you can get rid of fractions right away with radical sheet and transfer over. Here's what I mean by that. So you see these fractions are both thirds. Do you see 250 here? Nope. Do you see x here? Nope. Okay, so I can't really just get rid of it right away. Make sure there's no fraction exponents in the denominator. If there are, fix them. Nothing's on the bottom. Go to line 2, make the appropriate radical for all fractions you still have on top. Okay. So I still got fractions, both with a 3. So I make a cubed root. And I have 250 to the first and x to the first. Okay, line 3, carry everything over, but you got to simplify the radical with 250. That's what that says. Carry over, but simplify inside. So x second times y to the 3rd, radical 3. Put your x inside. We got to simplify the cubed root at 250. Since it wasn't here, we're going to divide. So 250 divided by 216 is a decimal. Divided by 125, you get 2. So that becomes 5. So the 5 goes to the front, the 2 goes behind, and that's my answer. 5x squared, y to the 3rd, radical 3, 2x. Okay, next one. Make the 3 lines. Rewrite the expression without the radical, so make it to the 1/4 power. 16 times x to the 12th times y to the 3rd. Line 1, write the bases, apply the exponents. That's an easy step. That's to the first. 1 times 1/4 is 1/4. 12 times 1/4 is 3. Use a calculator if you don't know it. 3 times 1/4 is 3/4. Okay, you got any negative exponents? Nope, don't have to rewrite it. Transfer all whole exponents to line 2. So x to the 3rd, transfer him over. Okay. See if you can get rid of fractions right away with the radical sheet and transfer it over. So we're on the 4 list because those are my fractions. 16's here, man. Okay, so how I get rid of that quickly, I cross that out and put 2, and it's now 2 to the 1st. Carry it over. Unfortunately, y is obviously not on the list, so we have to by the way, make sure no fractions are in the denominator. They're not. Go to line 2, make the appropriate radical for all fractions remaining. So you got the 4th root, y to the 3rd. Okay. Carry over, simplify the inside of the radical. You got x to the 3rd times 2. You really can't simplify anything in there. 4th root of y to the 3rd. Your answer is 2x. I don't care the order the outside is. I really don't. Okay. You can get that. It's awesome. Okay, number 3. Once again, there's no adding and subtracting operators. Make your 3 lines. Rewrite the expression without a radical. You got the same radical, so they're both to the 1/3. So it's all to the 1/3 power. So we'll take 9 times 24. 216. You only need one parentheses if the radicals are the same. 216. Y to the second times y would be y to the third. Okay. So my bases, write the bases, apply the exponents. 216 times y. 1 times 1/3 is 1/3. 3 times 1/3 is 1. You have any negative exponents? Nope. If you do, you got to rewrite it. Transfer all whole exponents to line 2, y to the first. Okay, that's gone. See if you can get rid of fractions right away with the radical sheet. Well, let's see if we let's look at the 3. The bottom number's the one you look at. 216's here, so get rid of it on the spot, and it's 6 to the first. We carry that over. Got any fraction exponents in the denominator? Nope. Go to line 2, make the appropriate radical for all fractions you still have on top. I don't have any fractions on top anymore, so no radical. Simplify it. It's going to be 6y. Okay, number 4, I gave you a little hint there. Get your line set up. Rewrite the expression without the radical, but you need 2 of them because you have a square root and a cubed root, so a half and a third. Both of them contain 3. Write the bases, apply exponents. The only base you have is 3. You don't repeat a base more than once using properties of exponents, because what you do in multiplying is you add a half plus 1/3. Half plus 1/3 is 5/6. Okay. Told you so. And we continue on. Do you have a negative? Nope, don't have to rewrite it. Transfer all whole exponents. I don't have any of those, so nothing's transferring yet. See if you get rid of fractions right away with the radical sheet transfer over. Well, I don't have a 6th root list, so I guess not. Okay. Make sure there's no fraction exponents in the denominator. There's not. If you are, fix them. There's a way to do that. That only comes up on one problem where you'd have to apply that. Go to line 2, make the appropriate radical for all fractions you still have on top. So we got a radical 6, 3 to the 5th. Carry over, but simplify the inside. Now, you can leave it like that. That's fine. Okay. You can't really simplify the 6th root because we don't know what the 6 are. You can circle that. That's an acceptable answer. You can also raise 3 to the 5th and just put 243. Okay. So either this or this. Okay. But anyway, you wouldn't be able to simplify it very much other than the 3 to the 5th. Okay. Number 5. Simplify. No adding and subtracting. Okay. Write the expression without the radical. Well, the problem is you got 2 different ones, so you need 2 parentheses, and you are dividing them, a half and a third. So we got x to the 7th, x to the 2nd. So I put x, so first I take 7 times 1/2, that's 3 1/2. But now instead of adding, I subtract. 2 times 1/3 is 2/3. Two and 5/6, okay. Okay, if you have a negative exponent, we don't, that's positive. Transfer all whole exponents to line 2, so x to the 2nd's transferred, okay. See if you can get rid of fractions right away at the radical sheet, so I don't even have a 6th root list, so obviously we can't get rid of that. Make sure no fractions are in the denominator. There's not even anything in the denominator on the bottom, so you're fine. Now go to line 2, make the appropriate radical for all the fractions you still have on top. So I need a radical 6. Okay, again, that we at minus got 2 and 5, 6, the x second transfer. Now I'm going to make a 6th radical with x to the 5th. Line 3, carry over, simplify. If you have a number in the radical, we don't, so everything's just going to carry over. Okay, number 6, same idea. Now, rewrite the expression without a radical. It's already done. There's no radical there, so I don't rewrite nothing, okay? So that's good. So write the base, apply the exponent. Just be 1 times negative 1 3/4 is negative 3/4. If you have a negative exponent, rewrite it below. Ooh, we actually have one this time. So 625 goes to the bottom where it goes to positive 3/4, so 1 up top. Okay, transfer all whole exponents to line 2. Right now I don't have any, well actually 1 is, okay? It's not doesn't even have a power, but it can transfer over. That one can, it's a fraction. Got to see if we can do something about that. See if you can get rid of fractions right away with the radical sheet and transfer over. So we're looking at the 4, 625. Oh, it's there, it's 5. So that's gone, and then 5 to the 3rd transfers over. Make sure no fraction exponents are, there's not, nope, it's a 3. Now it's just a 3rd power, okay? It's not a fraction anymore, okay? So I'm good with that. I got rid of the fraction. Go to line 2, make the appropriate radical for all fractions you still have on top. Don't have a fraction on top. Carry over and simplify. 5 to the 3rd is 125. Okay, number 7. Again, rewrite these. You already have it written without a radical. There's no radical there. Those fractions, those powers are the way we want them when we're using this technique. So you write the bases, x just 1, and apply the exponents. Well, it's multiplying, so it's a 3rd plus 1/5. 1/3 plus 1/5 is 8 over 15. Got any you got a negative exponent? Nope. Okay. Transfer all whole exponents to line 2. Don't have any whole exponents. See if you can get rid of the fractions right away with a radical sheet that can transfer over. I don't even have a 15th root, and even if I did, x wouldn't be there, so that won't work. Make sure there's no fractions in the denominator of the exponents. There's not, okay, because we don't want end up with radicals in the denominator. Go to line 2, make the appropriate radical for all fractions you have on top. So I make a radical of a 15 and x to the 8th. Line 2, carry over but simplify. There ain't much I can simplify. Okay, you just got the 15th root of x to the 8th. Okay, number 8. Once again, we're not rewriting that, okay? Because I don't have any radicals. It's all written as fractional exponents, rational exponents. So we got 16 and 81, and then times x times y. So 16, 1 times 3/4 is 3/4. 81, 1 times 3/4 is 3/4. X, we got 2. First we got to take 15 times 3/4. Got 11 and 1/4. Minus, because it's division, and I take 2 times 3/4. 1 and 1/2, okay? So I got 11 and 1/4 minus 1 and 1/2. Nine and 3/4, that's a big power. So we got a 9 and 3/4. X is to the power of 9 and 3/4. 9 and 3/4. Now y, same procedure, okay? So I take 8 times 3/4, that's going to be 6. 16 times 3/4 is 12, so that's a negative 6. Okay, if you have a negative exponent, you got to rewrite it, okay? So everything's the same. Everything with positive exponents is in the same place. times x to the 9 3/4, kind of a weird power, but the 9 then moves down so it can be positive 6. I can forget that. Okay, transfer all whole exponents to line 2. Well, I got a 9 and a 6, so I can write x to the 9th, y to the 6th. Okay. See if you can get rid of fractions right away, rational exponents right away with the radical sheet, and then transfer it over if you can. So we're looking at the 4s and 16s here, so that's 2. So it's now 2 to the 3rd. You can transfer that over on bottom, of course. Let's look at the 3/4, okay? Or no, I was wrong about that. Whoa, I messed that up. 16, I'm doing 16. 4th root of 16 is 2 to the 3rd. That would just carry over, okay? So 81 and 4, that's there as well. So that's 3 to the 3rd. Okay, so we got rid of those. Now, make sure you don't have any fractions left on the bottom. Nope, I didn't. Remember, I got rid of that one. That ended up being 3 to the 3rd. Okay, no fractions. Go to line 2, make appropriate radical for all fractions you still have on top. Now, I still got this 3/4 on top, so I make the 4th root of x to the 3rd. Okay, carry over, but simplify. So x to the 9th, 2 to the 3rd is 8, y to the 6th, 3 to the 3rd is 27. Then I have the radical 4 with the variable and the power, but no numbers inside. That's the answer. Technically, the 8 and 27 would go in front, but it doesn't matter. Okay, then the last one of these kind of problems. Again, no subtracting. To simplify it, this is your best bet. Okay, rewrite the expression without the radical. We make one parentheses, only need one because they're both 2 to the half power. I've got x over 6y. Write the bases, apply the exponents. X, 6 times y. Those are both first powers. Now multiply them all by a half. So a half, a half, a half. You don't have any negative exponents. You don't have to rewrite it. Transfer all whole exponents to line 2. Don't have any holes. See if you can get rid of fractions right away with the radical sheet, transfer over. So they're all 2's, so I don't think x is going to show up here. 6 doesn't show up, and y doesn't show up, so nothing happening there. Make sure no fraction Make sure no fraction exponents are in the denominator at this point. If there are, fix them. Well, you got fractions in the denominator. So remember, times 6. If that's a half, we need a half. By the way, if it's a third, you need 2/3. Or 1/3, or 2/3, you need 1/3, but a half goes with a half. Bring it to the top. Times y, because we also got a fraction on the y to the half, okay? Bring that to the top. Now what this does is I can write a single 6 times a single y, and a half plus a half is 1. A half plus a half is 1. So now those are forgotten, okay? And now they are fixed, they can be carried over as 6 times y. Go to radical 2, make appropriate radical for all fractions you still have on top. Well, we got 3 fractions on top, all with a 2, so we make a radical 2. X to the 1st times 6 to the 1st times y to the 1st. Line 3, carry over, you just simplify 6 times y on bottom. You just got the radical, x, y, okay. Let's talk about that 6, okay. 6 to the 1st, well, that's 6. 6 would not be out, you just divide, only thing you can divide it by is 1, which is useless, so I keep 6 in the radical. Okay, now the game changes. Now this starts trucking around a little bit quicker because now you see a plus sign. Well, this is a shorter story. See if the insides match. Okay, they do. So, if they do, you add the outsides. You make the radical that matches, and 4 plus 10 is 14. Boom. Okay, what happens if they don't match? Use this little table to get them to match. So we got 3 radical 20. These are square roots. 8 radical 45. 4 radical 5. Okay, let's look at 20. 20 divided by 16 don't work. Divide by 9 doesn't work. If you divide by 4, it's 5. So 3, 4, 5. So that's 2. Now remember, that's 3 times 2 times radical 5. So that'd be 6 radical 5. You don't add the 3 and the 2. 6 radical 5. Because within that, there's no adding. In the whole problem there is, but just within that, no adding. Okay, 45. 45 will divide by 9. So I drop the 8. 9, 5. That becomes 3. Remember, it is 8 times 3, not 8 plus 3. That's 24. So plus 24 radical 5. And 5's not going to divide by anything other than 1, so that's simplified. So minus 4 radical 5. Now I make the radical 5 and I simplify the outside. 6 plus 24 is 30, minus 4 is 26. Okay, FOIL, but I gave you a hint of something you got to do first. You got to take this 3 radical 27, that staple got in the way. It says 3 radical 27, and see what 27 can divide by. Up there where the staples, it's 3 radical 27, okay? So I carry my 3. 27 divides by 9, okay? So 9 and 27 divided by 9 is 3. So that becomes 3. So we have 3 times 3 times radical 3, and that would be 9 radical 3. So before we FOIL, rewrite that one. 5 plus 9 radical 3 times 4 minus 1 radical 3, and now I can FOIL. So 5 times 4, 5 times negative 1 radical 3. It's like there's an x connected to it. 9 radical 3 times 4, and 9 radical 3 times negative 1 radical 3. So 5 times 4 is 20. 5 times negative 1 is negative 5 radical 3. It's going to be 36 radical 3. That's going to be negative 9, but you got to multiply the radical 3's, that's 9. Now radical 3's can't be simplified, but a radical 9 we rewrite as 3. So it's negative 9 times 3, which is negative 27. Okay, you add those, that's negative 7. Then you can add these because they have the same radical. That wouldn't have happened if I didn't simplify at the beginning. Negative 5 plus 36 is 31. So you add these, remember, put the radical 3. Okay, another minus, we stay on this side. See if the insides match or don't. They don't, use the table. So radical 8, remember we're on this list if it doesn't have anything. Okay, 8. 8 will divide by 4. So put 4, 8 divided by 4 is 2, so that is 2 square root 2. Minus 18 divisible by 9. So I had 9 and 18 divided by 9 is 2. So that's 3 square root 2. And again, the insides match. Now you can do the math. 2 minus 3 is negative 1. So again, that sheet's key. Okay? No adding and subtracting, makes for a longer process. When you have adding and subtracting, this is the way to go, except of course for the FOIL. Okay? Okay, solving equations. This is a quick one. Check outside your radical. Yeah, you got a plus 3. That's 18. Then you got to divide by the 3. That equals 6. Now you can get rid of your radical. So it's going to give us 2x plus 6. 6 to the second power is not 12. It means 6 times itself. That's 36. then we minus 6, and that's 30. Then we divide by 2, and that's 15. One answer. Okay, number 15, solving for x, but when I have x to the parentheses to an entire power, we can't distribute, so let's simplify it. Put the q, 4 in front, to the 2/3 power equals 36. Then remember to make your table where you bring back the 3x minus 3 expression. Now that top number is the one I pay attention to as if I need the both columns. It's even, so I need both of them. Now I proceed. Now, you reciprocate the power. When you have a rational exponent, you reciprocate it. Rational exponents are these fractions. Okay, now remember how you can simplify that. You go check your square root list. 9's in the house, it's 3, but it's 3 to the 3rd power. And 3 to the 3rd power is 3 times 3 times 3 is 27. So you put 27, negative 27. So that's 30 divided by 3, I get 10. That's negative 24 divided by 3, I get negative 8. Okay. 3 more. Okay, there's your radical, nothing outside of it, so you can go to your second power. That cancels, this doesn't, okay? You have to use the FOIL to simplify it. So that means x plus 4 times another one, just like another binomial just like it. So it's x squared, 4x, 4x, and 16. That does not cancel, it makes 8x. So I have x squared plus 8x plus 16. Now that turns into a quadratic equation where there are 2 solutions. So clear this side. So it's going to give us x to the second plus 7x plus 10 equals 0. By the way, just for craps and giggles, I'm going to use that b squared minus 4ac, so 7 to the second minus 4, 1, 10. Okay, it's a whole number, so I know the t-chart works. The GCF's a waste of time, but the t-chart will work. 1 times 10 is 10, positive, so you go negative, negative, or positive, positive. You add to positive 7. 1 and 10, no way. 2 and 5, yep, but it's positive 7, so plus, plus. After I find them, what's my A? My A is 1. You can just write it as x plus 2, x plus 5 equals 0. So x plus 2 could equal 0, or x plus 5 could equal 0. So I minus 2, you get negative 2. I minus 5, you get negative 5. Okay, graphing, radical functions. They're both square roots, so set up your parent graph of a square root function. You can't have negatives in that square root. 0 would be the last possible one going that way. 1, 4, 9, I'd go 16, but that's good enough. Then if I put those in square roots, you get 3, 2, 1, 0. Now, there's nothing inside the radical, so the x is set. Okay? Also, you got to do the domain and range. Okay? Put D and R up here, X, Y, okay? Now, outside, you got a times 5 and a plus 9. So 3 times 5, 15, plus 9 is 24. 10, that's going to be 19. 1 times 5 is 5, plus 9 is 14. 0 plus 9 is 9. 0, 9, let's go by at least 2's, I'd say, okay, just to get at least more than 1 point here. 0, 9, 2, 4, 6, 8, right there. Label that point because that's where your domain and range is based, okay? 1, 14, 2, 4, 6, 8, 10, 12, 14. Now the rest of it's off the graph. I at least got a couple points though. Okay, so it's graph, that's good enough. Now I make through that point, that first one, a straight vertical line, everything's to the right, so greater than or equal to 0. Straight horizontal line through that point. The graph is above it, so greater than or equal to 9. That's beautiful. Okay, 18, same thing, same setup at the beginning because it's a square root, 0, 1, 4, 9. Okay, you do have to do something with the x because you got a minus 2 within that, okay? So you're going to do the opposite, plus 2. Remember, because 11 minus 2 is 9, which is what I want there to begin with. It's going to be 6, 3, and 2. So that's done. Now the outside, you got to, you had 3, 2, 1, 0. Then you add 3 to all those. So 6, 5, 4, 3. So 2, 3. Okay, remember D and R. So 2, 1, 2, 3. 2, comma 3. 3, 4. Just going to be forward right there. 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 11, 6. So off the graph, just go with what you got. Okay, 2 and 3. That vertical line, the points are all to the right. So that's right on the x is greater than. Horizontal line, all points are above, so that's greater than 2. Okay, made pretty good time on that.